Hey everybody, so this goes back a chapter. We're going to be talking about the exponential functions and we're going to be talking about logarithms, get everybody caught back up. But before we can even talk about exponentials, we need to go back over some of the background material that you should have known before you came into the class. So we'll get everybody caught up on feeling comfortable working with exponents. So there's a whole bunch of things that you're going to see going on throughout the course, and in order to deal with the exponential properties, we're going to need to practice the basics a lot. So let's go ahead and write out some of these. We have a to the x to the y equals a to the xy. We have ab to the x equals a to the x, b to the x. What I want to do is I want to start with these two. These are two that people tend to sort of mix up, so let's go ahead and get started on working with these. We're going to call this 1, we're going to call that 2. So let's practice 1, 2 cubed squared. That's one way of writing it is 2 cubed times 2 cubed, which is 2 times 2 times 2 times 2 times 2 times 2, which is definitely 6 2's in a row, right? But if we use our regular rule, and we look back here, and the one I'm doing is rule 1, it says that if we do one power followed by another, we can just multiply the two. So it's 2 to the 3 times 2, and 3 times 2 is 6. And see how we got the same thing? So that worked out just fine. X cubed to the 4th. Well, x cubed is x times x times x, so I could write that as x times x times x, and the 4th power tells me to do that 4 times. Right, there's x cubed, 1, 2, 3, 4 times. But if I use my rule, x to the 3 times 4, 3 times 4 is 12, it's x to the 12th, which is definitely the same as what's going on up here, right? Because there's 12 x's, because we wrote 3 x's 4 times. How about x to the 12 to the 3rd? Remember, another way of writing this is the cube root of x to the 12th. Well, that's just x to the 12 times 1/3, and 3 goes into 12 4 times, so that's just x to the 4th. So that's property 1. Now property 2. What is x, y cubed? Well, that's just x cubed, y cubed. How about ABC squared? Well, that's going to be a squared, b squared, c squared. And you can do this the long way, and you can write it as ab squared, c squared, which you can then write as a squared, b squared, c squared. But just know that whenever you have any number of things being multiplied, being raised to some power, that you just take each of the things to that power. So let's try something a little more complicated. What if we had x squared y cubed squared? Well, we know, in the back of our head we should be thinking, if we have ab squared, that's a squared b squared. Well, here a is x squared and b is y cubed, so we have x squared squared y cubed squared. And then in the other part of our back of our head, we should be thinking that a to the x to the y is a to the xy. So x squared squared is just x to the fourth, and y cubed squared, well, 3 times 2 is 6, so that's y to the sixth. Alright, a couple more rules. A over b to the x is a to the x over b to the x. That kind of looks like rule 2 here, right? Rule 2 says a times b to the x is a to the x times b to the x. What we can call rule 3 is going to be a over b to the x is a to the x over b to the x. So this is going to be sort of synonymous. And let's go ahead and practice one of those as an example. If I have x squared y over zw cubed squared, well, that's x squared y squared over zw cubed squared. Now, from our previous rules, if we have x squared y squared, we're going to square x squared and we're going to square y. And so we're going to get x to the fourth y squared over z squared w to the sixth. So there's a lot of things happening inside of here. We're using all of rules 1, 2, and 3 in one shot. The next two rules, if I have, let's go ahead and number this 4, a to the x times a to the y, this is going to be a to the x plus y, and 5 a to the x over a to the y is going to be a to the x minus y. And so both of these feel a lot like each other. Again, you can notice that there's a general pattern where multiplication and addition and division and subtraction sort of go hand in hand. So let's try practicing this. X cubed times x to the fourth. Well, if we look at it as what it means, x cubed is just x times x times x. And x to the fourth is x times x times x times x. And if you look really closely, you can see 1, 2, 3, 4, 5, 6, 7 x's. So the answer should be x to the seventh. And our rule tells us that this is x to the 3 plus 4, which is x to the seventh. So it works out really well. And it's a much shorter method than having to write out what everything means and then putting it back together. Well, how about x to the fourth divided by x cubed? Well, we can do this again the long way. We go x times x times x times x over x times x times x. And we can cancel one up top and one below, one up top, one below, one up top, one below. And what do we get? We get x. But if we use our rule, right? If we use our rule, it should be x to the 4 minus 3, which is x to the 1, which is also x. And so that worked out okay. Good. So these are some of the basic rules of exponents. Let me give you another crucial rule. 6. The nth root of x is the same thing as x to the 1 divided by n. So if I write the cube root of x, I can write that as x to the third. Let me make that look a little nicer there, x to the third. If I write the square root of x, well, secretly hiding up here is the number 2. And so this is x to the half. We generally prefer, especially when we're doing calculus later, to write exponents instead of roots. They'll help us with all sorts of things as we move forward. More importantly, they allow us to simplify things. So another example, what if I take the cube root of x to the sixth? Well, this is x to the sixth, and when we use our last rule, to the third. So let's use a previous rule. Do you notice how we have two exponents in a row? That rule was given by multiply the numbers. So the answer is x to the sixth times 1/3, and a third of 6 is 2, so that's x squared. So the cube root of x to the sixth is x squared. So that's basically all of the most important rules that we have going for us. Let's do one more practice with a couple of things. Let's do x squared y cubed over xy squared. Well, what we're going to have to do is break this down into a couple of steps. We're going to cube x squared on top, which is going to give us x to the sixth. And we're going to cube y, which is going to give us y cubed. We'll square x on the bottom, and square y on the bottom. So that takes care of the outer exponents. You can see that they have been distributed to the current exponents. Now we have to use our subtraction rules, and we can use each rule only for each letter. So we have x to the 6 minus 2 times y to the 3 minus 2. 6 minus 2 is 4, so I'm left with x to the 4th. And 3 minus 2 is 1, so I'm left with y. There's my final answer. So that's it for the basics. At this point, you should know how to simplify certain expressions with exponents. And so I want you to go ahead and try some of the homework, and I will see you in class.